Hi there, welcome to my channel. In this video, I'm going to discuss about the solution for copying list with the random pointer. Let's look at the problem description. We are given a linked list of length n such that each node contains an additional random pointer that could point to any other node in the list, or it could be null. Okay, and we have to construct a deep copy of that list. So the new list should be representing the original list state, and we have to return the head of the copied linked list. So the linked list is represented as a list of n nodes where each node is represented as a pair of value comma the random index. And let's take a look at the example 1. So in this there are 5 nodes, and the first node next pointer points to 13, and that next pointer points to 11, next pointer points to 10, next pointer points to 1. But in the case of random point, if you follow the random pointer, the random pointer of 7 points to null, the random pointer of 13 points to 7, and the random pointer of 11 points to 1, and the random pointer of 10 points to 11. So the input and the output list state is same thing for the example 2, and for the example 3 all the values are same. We have to keep this in mind when we design the algorithm. And the constraints for this problem are the number of nodes is ranging from 0 to 1000, and the node value will be ranging from minus 10,000 to 10,000, and then the random pointer may be null or it is pointing to some node in the linked list. Let's look at the approach to solve this problem. So basically we have to create a deep copy of this list. So if you look at this linked list, the random pointer may point to the node which is before the current node or after the current node. For this node, the random pointer points to null, and for this node, the random pointer points to the node before that node, and for this node, the random pointer points to a node which is coming after that node in the linked list. Okay, so when we create a copy, we cannot update the random pointer if the node is present after the current node. In that case, we need to store the mappings between the node in the current linked list and the copy created for that node. Okay, so basically we need to maintain a mapping, or we need to use a hash map which maintain the mapping between the node in the old linked list and the corresponding node in the new linked list. As we traverse the input linked list, we check whether there is an entry for the current node in the created nodes hash map. If there is no entry in this map, we allocate a new node and copy this value and then create an entry in this hash map. After creating a copy of this node, next thing we have to do is, if the random pointer is not null, for example in this case the random pointer is pointing to node 1, then we check whether this node 1 is then we check whether there is an entry in the created nodes map for this node. If it is not, then we simply allocate a new node and copy this value and update the created nodes map, and then we update the random pointer of the new node created for this node. Okay, and we repeat this until we reach the end of the list, and finally we get a copy of this original linked list and that also represents the same state, like the random pointers points to the correct element as it is in the original input list. So that's what I have listed here. First we initialize this created nodes map, and then this basically stores the mapping between the old node and the new node for each node created. Then traverse the linked list. In each iteration, if there is no entry for the current element in the created map, then create a new node and add an entry in the hash map, and then add the new node to the new linked list. Then we check if there is no entry for the random pointer in the created nodes map, then create a new node for that element pointed by that random pointer and add an entry to the created node map. Then update the random pointer of the new node we created here. We repeat this until all the nodes are traversed. Let's look at the flowchart. Input for this procedure is the head of the linked list, and first we initialize the created nodes map, and then we initialize the new head and new tail pointers. Okay. Then we start traversing the linked list. We check whether the head is null. If so, we break out of the loop. Otherwise, we check whether there is an entry for that head pointer in the created map. If there is an entry, there is a copy created already for that node. If there is no entry for that node, then we create a new node and then add an entry in the created nodes map, and then add the new node to the tail of the new linked list. Once that is done, then we check whether the current node's random pointer is not equal to null. If it is not null, then we check whether there is an entry in the created nodes hash map for this random pointer. If there is an entry, then that node is already copied. Otherwise, we allocate a new random node and add an entry to the created nodes map. Once that is done, then we update the random pointer of the new node created, and then next the head pointer is updated, and this process is repeated until we reach the end of the list. Once we reach the end of the list, the new head will be returned. Let's move on to coding. First I initialize the new head and the new tail pointers, and then I initialize the created nodes hash map. This will have an entry for each node created so far as we traverse the linked list. Then I write the for loop. This will run as long as it is not null, and I define the element node and the OK boolean. Next I check whether there is an entry for the head pointer in the created nodes hash map. If it is not, then I create a new node, allocate a new node and copy the head node's value. Add an entry in the created nodes hash map. Next I add this element to the new list. If the head is null, I set the current element as both head and tail. Otherwise, I update the tail pointer. Next I check whether the random pointer of the head node is not equal to null. If it is not null, then I check whether there is an entry in the created nodes hash map. Then I check whether there is an entry for the random pointer in the created nodes hash map. If there is no entry, then I create a new node for that node pointed by the random pointer. Then I update the random pointer of the newly created element with the new random nodes pointer. If there is an entry already exists in the created nodes map, then I assign that new random pointer in the current elements random field. Then I update the head pointer, advance the head pointer. And finally I return the new head. After creating a node, I have to add an entry in the hash map also. Next I am going to run the test cases. All the tests passed. Next I am going to submit this program. Cool, this program is accepted. Next I am going to do the code walkthrough with the sample input. Let's do the code walkthrough for this input. First we initialize the new head and new tail pointer to null, and then we initialize the create nodes hash map to empty hash map, and then we enter the for loop and we check whether the head is not equal to null. Yes, it is. Then we check whether there is an entry in the created nodes for this 7. It is not, so we create a new node and add it to the new head, and then we add an entry that maps this node and this node. And in the iteration 1 we traverse node 13 and we check whether there is an entry in the created nodes. It is not, then we create a new node and add it to the new list, and then add an entry in the created nodes that maps the old 13 and the new 13 pointers in the hash map. And in the iteration 2 we traverse node 11. Okay, we check whether there is an entry in the created nodes hash map. It is not, then we create a new node 11 and add it to the new list. Then we check whether this node's random pointer, whether there is an entry for the node pointed by the random pointer of this node, which is 1, and there is no entry for that node as well. So we create a new node for the node pointed by the random pointer and add it to the, it is not linked to the new list, but the node is already created and an entry is added in the hash map. Okay. And in the iteration 3, we traverse node 10 and we check whether there is an entry in this created node. There is no entry, so we create a new node and add it to the new list, and also add a mapping in the created nodes hash map. Then in the next iteration we traverse node 1 and we check whether there is an entry in this hash map. Already there is an entry, so we are not creating a new node for that node. Instead, now we link that node to the linked list. So if you see, earlier this node was not linked, but here that node is linked to the linked list. And then we check whether there is an entry for the node pointed by the random pointer. That entry is already there, so we simply update the new node's address of the new node 7 in the random pointer field of this node. So finally we get a new linked list that is representing the same state of the original linked list. Next, I'm going to do the time and space complexity analysis for this solution. Let's do the time complexity analysis for this solution. So for this input, there are 5 elements present in this linked list. This loop performs 5 iterations. If there are n elements in the linked list, that will perform n iterations. So the time complexity is order of n. And the space complexity is also order of n because we are using the hash map whose size will be equal to the total number of elements in the linked list. For each node in the linked list, we have one entry in this map. So the space complexity is also order of n. Thanks for watching this video. Have a great day.